Hi there, and welcome to the first training session of the MK Ultra Wideband Kit. My name is Carlos Paternine and I will be your speaker in this session. The session is divided into different modules. You will be able to navigate between them as you want by selecting the specific module. You can do so on the right-hand side of your screen. Our recommendation is that at least once you go through all of them in the defined order. Good. So what we will see today. We will start with a short introduction to ultra-wideband technology. We will then take a look at how ultra-wideband works. After that, we will look into the use cases where ultra-wideband is of extreme relevance. And to enable those use cases, we will have a look into the NXP Trimension ultra-wideband portfolio of products for IoT applications. And also describe the typical ultra-wideband solution architecture for IoT devices. Finally, we will guide you through the MK Ultra Wideband Kit, describing what does it contain and what are you able to do with it, including a look into the Ultra Wideband Kit roadmap and what comes next. So if you're ready to learn about Ultra Wideband technology, let's get started. Yeah? Ultra Wideband is a radio technology based on EEE standard, which spreads energy over a very wide frequency band and uses very low power spectral density. On the one hand, the low power spectral density limits the potential interference with other narrowband signals and ensures a high robustness on signal integrity as it is below environmental noise. This makes the communication highly efficient in terms of spectrum resources and more secure than other wireless technologies while requiring lower power consumption. On the other hand, the ultra-short duration of pulses, which equals to a high bandwidth, enables high ranging accuracy, robustness to multipath effect, and high data rate for short distances. In fact, ultra-wideband technology is not a new technology at all. It was already introduced in the early 20th century. However, due to a couple of recent key evolutions. First, the evolution from an OFDM-based data communication to an impulse radio technology. And secondly, the security extension at physical layer level, ultra-wideband has gained importance and it has become extremely relevant for a variety of applications and use cases by providing secure and high precision ranging capabilities. Actually, one of the triggers of its recent popularity was Apple's announcement that its iPhone 11 Pro including an ultra-wideband chipset, car access being the main driver for initial adoption. Since then, many other mobile and device manufacturers are following the same direction. So ultra-wideband capabilities make it unique within the wireless technologies. Let me summarize some of the key differentiators of ultra-wideband technology. It is secure. The integrity of the ranging result is provided through physical layer level security. It is real-time. Ranging measurements can be done 200 to 1000 times per second due to an ultra-short pulse use. It coexists very well with Bluetooth and Wi-Fi technologies due to the wide frequency band used by ultra-wideband. It is reliable and immune to narrowband fading and shadowing. It is accurate, providing accuracy at centimeter level, even in dense multipath environments, and it uses very low energy to do a very short pulse transmit over the air. But how does ultra-wideband compare to other wireless technologies for ranging? Other wireless technologies like Bluetooth Low Energy or Wi-Fi also provide ranging measurements, but their accuracy is around plus minus 150 centimeters. The same kind of ranging measurement use case, but using ultra-wideband instead of BLE or Wi-Fi, you can get around plus minus 10 centimeters accuracy. On top of this, with NXP ultra-wideband products, you can also get the angle information along with the ranging measurements. So the target device can be narrowed down to a very small area, as shown in the diagram. As a result, ultra-wideband provides a solution to an unresolved problem. The characteristics of ultra-wideband technology in terms of bandwidth, signal propagation, time of flight, and angle of arrival measurements make it unique, and it is the only technology able to provide precise, secure, and accurate positioning data of objects in real time, even in scenarios where objects or humans are blocking the direct path and there is no direct line of sight. As a result, ultra-wideband precise localization with enhanced security and no power compromise improves the ranging of other wireless technologies and enables many use cases. But when it comes to deploying the technology and ensuring a wide adoption, there are several organizations which are standardizing and regulating ultra-wideband adoption. Only by developing compelling use cases and specifications and ensuring seamless ultra-wideband interoperability between mobile devices, IoT devices, and vehicles will the technology be adopted. We would like to highlight here a couple of organizations that are trying to make this happen. FIRA Consortium, which stands for Fine Ranging, has as main objectives to create opportunities by identifying and developing use cases, defining the technical requirements and test certification programs to ensure interoperability, support the deployment of ultra-wideband ecosystem, which is rapidly growing as they now count on more than 60 members at the end of 2020. Another example is the Car Connectivity Consortium, which is driving the ultra-wideband standardization as a digital key for your vehicle. This is an exciting new open standard to allow smart devices like smartphones to act as hands-free vehicle key and one of the key drivers of ultra-wideband adoption by smartphone manufacturers.